تأكد بسجل. تمام. What we are going to cover today inshallah, module 3 and module 4. Both of them talking about the VLAN, virtual local area network. So we need to understand what's the VLAN. Later on we will talk about the types, network management, configuration, and some other issues. Now, what's the VLAN? Virtual Local Area Network. Simply, VLAN provides ability for a segmentation and organizational flexibility for our switched network, which means I can divide my LAN into multiple VLANs regardless of the hardware location. Means we have 3 different switches here, and every switch or every PC, for example, linked with this switch belongs to different virtual VLAN. So as we see here, we have 3 different VLANs, VLAN 2, 3, 4, different devices connected with different switches can communicate with each other without any problem, regardless of their physical location. Why? Because they are assigning or associated to the same VLAN. So it's like all of these devices connecting now on the same network with a similar link or the same link. So simply VLAN allow the administrator in this case to segment the network based on their functions, based on the application, using any other, for example, concepts to segment the network. Now, regardless of their physical location, without any regard for the physical location in this case. So every VLAN here will be considered as separate, independent logical network. Please focus, logical network, because it's a virtual network, VLAN. So any devices within the same VLAN here can act as they have their own independent network. They can communicate with each other as they are attached to the same network cable. So according to this figure, we have extended or expanding or segmenting our LAN into 3 different VLANs. As you see, all devices within the same VLAN can communicate with each other as they are connecting to the same network within the same cable, which means as they are attached to the same switch. So this is the main benefits of the VLAN. So in case we have a broadcast message now, it will be only received by the devices associated with VLAN 2 only, or VLAN 3 or VLAN 4, depending on the tagged VLAN ID, which will we talk about it later. So VLAN logical connection with other similar devices. Placing a devices into different VLANs have the following characteristics. What's the benefits of dividing the network into multiple or several VLANs? Segmentation. Provides segmentation of various groups of devices on the same switch. So different devices will be grouped together as a group of one VLAN. Provide organization that is more manageable. Managing, controlling, maintaining the network will be more simpler and easier. Why? For example, broadcast, multicast, and unicast are isolated in the individual VLANs. Any broadcast will be only received by all devices attached, let me say, to the same VLAN. So, In this case, what we are going to have a smaller broadcast domain. So in case we do not have a VLAN here, if any PC send a broadcast message, it will be received by all these devices in this LAN. While in case we are talking about a VLAN, only a devices within the same VLAN will receive a broadcast, unicast, broadcast, multicast, or unicast data traffic. Now, each VLAN will have a unique range of IP addressing as well, and unique subnet mask for sure, because we are talking about a unique range of IP addressing. Smaller broadcast domain, better network for performance, and improving what? The network speed in this case, because only a limited number of devices will receive the broadcast message, not all of the devices within the same VLAN. So what's the benefits of using the VLAN? As you see here, how many VLAN we have? Let us understand this figure. We have 3 different VLANs. One of them called faculty VLAN, and the ID of the VLAN is number 10. Students VLAN, ID number of the VLAN is 20. Guests, and the ID is 30. Now check the IP address. Every VLAN has a unique range of IP addresses. So what's the default or the subnet mask here? Default network address 172.17.10.1, 2.17.20.1, or it should be .0, sorry. 172.17.20.1, different range of IP addresses. Now, we have multiple switches, and we'll talk about the link between these 2 switches later on, and the link between a device and a switch. So in case BC1 want to send a message to BC4, as you see, BC1 here and BC4 associate with the same VLAN. So simply the message will be sent to the switch through fast Ethernet 011. Message will be forwarded to this switch. Let us say S1, S2. S2 will forward it to S3. S3 will only forward this message to all devices or to the device associated with VLAN 10. So only BC4 will receive the message in this case. So as you see, multiple switches. When we segment the network into multiple VLANs, all the devices attached with different switches will act as they are connecting to the same cable. They can communicate with each other without any problem. So what's the benefits when we use or segment our network? Dividing the LAN reduce the number of a broadcast domain. Now without LAN, without local area network, where is the broadcast domain? All of these devices except of the sender and the router. This is the broadcast domain according to our last class. Improve the security. Only users in the same VLAN can communicate together. Improve the IT efficiency. VLAN can group devices with similar requirements. For example, faculty on a single VLAN, students in a different requirement VLAN, guests in VLAN 30, and so on. Reduce the cost. One switch can support multiple group of VLANs. As you see here, a single switch supporting VLAN 10, 20, and 30. And before we start, I want to mention an important comment. VLAN configuration will be configured at the switchboard. When we started the class, we say the VLAN is virtual VLAN and it's a switched network. So the switch port will be configured to be associated with VLAN or specific a group of VLANs. Better performance, smaller broadcast domain, lower traffic, improving the bandwidth. Finally, simpler management, while a smaller group will need similar application and other network resources. Now, what's the types of a VLAN? Now, before we start with the type of VLANs, is it clear the basic, the main concept of the VLAN? واضح الكونسبت بتاع الفيلان؟ يعني let me give you an example. نفترض ان اللوكال نتورك جميع طلاب ال T216. الان ممكن نساوي سب جروبس اللي بالمنطقة الشرقية لواحد، اللي بالرياض لوحدهم، اللي بالمنطقة الغربية لوحدهم. طيب هذه فيلان وهذه فيلان وهذه فيلان بالحالة هذه كسبيل المثال. طيب VLANs in general used for different reasons in modern network. Now we have a different types. Some VLAN types are defined by the traffic. Other types are defined, for example, by specific function they serve or provide. Now, before we talk about VLAN types, we need to talk about the default VLAN. We have a default VLAN already available in all Cisco switches. By default, it's already created and configured as a default VLAN. So the default VLAN on Cisco switches is VLAN 1, VLAN ID 1. All switch ports by default are on VLAN 1, unless we want configured to be another VLAN. VLAN 1 is the default VLAN in all switches. By default VLAN. VLAN 1 is the default native VLAN as well. And we'll say what's the native VLAN later on. VLAN 1 by default is the default management VLAN as well. And most important notes, it cannot be renamed or deleted. So any Cisco switch will be configured by default, all the ports on VLAN 1. Management VLAN is VLAN 1 by default. Native VLAN is VLAN 1 by default. Can we delete it or rename it? No. So while we cannot delete VLAN 1, Cisco will recommend that we assign these default features to other VLAN. It's insecure to keep the default VLAN VLAN 1. So as you see here, we have issued the command show VLAN brief. So this command will list all the VLANs configured and the port associated to each VLAN. As you see here, we have only one VLAN. VLAN ID is 1. The default VLAN. It's active. All switch ports by default associated with or assigned VLAN 1. VLAN 1 also it's what? Native VLAN. Default VLAN. Default management VLAN as well. Now, we have 3 types of VLANs. First one, let me user traffic VLAN, say it's called data VLAN. Data VLAN dedicated for or to user generated traffic, for example, the email and web traffic. Keep in your mind, VLAN 1 is the default data VLAN by default, because all interfaces or all switch ports are assigned to this VLAN by default. Which VLAN is the default data VLAN? At the beginning, VLAN 1. So any network may have many data VLANs depending on the organizational requirement. But we have here a note: voice and management traffic should be or should not be allowed on data VLANs. Data VLANs only user traffic, user data, like email, web traffic, any other user-generated data. Now, for the second one, please focus here, native VLAN. Now, usually it's used for the trunk links only. What's the trunk link? The link between two switches or two network devices, switch and router, is the trunk link. So here we have 1, 2, 3 trunk. Can we consider the connection between the PC and the switch as a trunk? No, this one is an access port. So native VLAN used for a trunk link only. Now, to understand what's the main idea of the native VLAN, now you need to know all user traffic, all the traffics or the frames comes from the user must be tagged with VLAN ID. This frame should be linked or associated to which VLAN? VLAN 10 or 20 or 30, according to the previous figure. So user traffic must be tagged with VLAN ID when it's sent to another switch. So the trunk port here will be used between the switches to support the transmission of what? Tagged traffic. So faculty PC1 can communicate with faculty PC4 through the trunk link. Now, when PC1 send a data frame to PC4, data on the switch or on the trunk connection should be tagged. This message or this frame should be sent to any device with VLAN 10. So this is the tag here, the VLAN ID. Now, by default also, for the trunking ports, for the trunk, all the frame will be tagged by using IEEE 802.1q trunk link standard, which is a 4 bytes will be inserted inside the Ethernet frame used to identify what? The VLAN ID. So one more time, any frame or any user traffic should be tagged with VLAN ID. How we will tag the VLAN? By using standards, IEEE standard 802.1q. Now, this is the normal situation. Now, what's the requirement of native VLAN? Why we need native VLAN? Simply, the switch may have to send untagged traffic. Now, sometimes across what? The trunk link, which means we have untagged traffic and should be sent through the trunk link. Now, untagged traffic can be generated by management traffic or management VLAN, or it can be generated by the switch and some legacy let me say, devices like some types of the hubs or some types of an access point. Now, what's the action we should take when the switch port on the trunk receives untagged traffic? Simply, untagged traffic should be tagged by using IEEE 802.1Q. Now, untagged traffic will be tagged to be placed, or let me say, or to be sent to what? To the native VLAN. So any untagged traffic, frame or traffic on the trunk port will be tagged with a native VLAN, and it will be placed on the traffic of the native VLAN. يعني سهلكم الموضوع أسرع. كل فريمز لازم يكون فيها VLAN ID، نسميها تاج فريم. الآن عشان نساوي تاجينج محتاجين ستاندرد، الستاندرد 802.1Q. الآن السويتش وبعض الديفايسز زي الهابس والاكسس بوينتس ممكن يساوي جنريت داخل الترانك لينك، الترانك اللي بتوين السويتشز، تمام؟ ويطلع عندي untagged frames or untagged traffic. الآن ال untagged will be tagged to be placed on the native VLAN. معناها any frame which is untagged will be tagged with what? As to be forwarded, let me say, to the native VLAN on the trunk. هذا المين benefits بالنسبة للnative VLAN. In order to handle and process the untagged traffic comes or generated from the switchboard or some other devices connecting to the switch. And remember, native VLAN used for the trunk only. What we mean by trunk? A point-to-point connection between the switches. So between gigabit 001 and on a switch, let me say 1 and the switch 2, F03 and F03 with S2 and S3. It's a trunk here link. Now, management VLAN, this is used for SSH, Telnet, virtual teletype traffic, HTTP, HTTPS traffic, usually the traffic generated from a workstation in general and should not be carried with end user traffic. When we talk about the data VLAN, we say user data VLAN should not permit the management traffic and the voice traffic. Finally, voice VLAN now. Now, voice VLAN should be configured as a separate VLAN because of the voice traffic requires the following. It should be a separate VLAN configured separately. Why? Because voice traffic requires assured bandwidth, quality of service priority, ability to avoid congestion, delay should be less than 50 milliseconds from source to the destination. Now, the entire network must be designed to support voice traffic as well. Now, as we can see here in this example, we have VLAN 150 is designed to carry the voice traffic. This one. Okay. Now we have a student PC5 computer attached to Cisco IP phone. And the phone is attached to S3 as you see. Now, PC5 is in VLAN 20. It's a data VLAN here. and it will be used for student data. Now, IP device is a voice traffic, so it will be in VLAN 150. As you see here, both of them connecting to the same switch port, F018 on AC3. So this port will be configured to support two VLANs, 150 for voice and 20 for user traffic or user data VLAN. But most important, VLAN should be configured separately. And on the same port, we might have multiple VLANs. So in this example, Fast Ethernet 018 is assigned or associated to two VLANs, data VLAN 20, voice VLAN 150. Any question? So we talk about the concepts, main VLAN types. في استفسار للآن؟ طيب now VLAN with a multi-switched environment. As you see here, we'll starting talking about the VLAN trunk. Remember, VLAN trunk is used in case we have generated untagged traffic. It will be tagged with a native VLAN here, and trunk allow or serve multiple VLAN attached with different switches to communicate with each other. Now, so the trunk is a point-to-point link between two network devices or two switches. So here we have two trunks between S2 and S1, between S1 and S3. Now, what's the benefits? Why we need VLAN? VLAN trunks allow all VLAN traffic to propagate between the switches. So BC1 can send the traffic to BC4. BC2 can send to BC5. As you see, same VLAN. BC3 and BC6. Now, how the traffic will propagate from a switch to a different one within the same VLAN? By using the VLAN trunk. This is the main function of the VLAN trunk. So VLAN trunk enable devices connected to different switches but in the same VLAN to communicate without needs to go through the router. So we do not need any routing here. We will use the VLAN trunk to allow different devices on different switches to communicate within the same VLAN. As we have said, the trunk is point-to-point between two network devices, and that trunk will carry or carries more than one VLAN. As you see here, the trunk carrying the data from VLAN 10, 20, and 30. Between S1 and S3, same concept, VLAN 10, VLAN 20, VLAN 30. So, main function of the Cisco trunk, allow more than one VLAN traffic to propagate between the switches, extend the VLAN across the entire network, and by default, it will support all VLANs. By default, it's supporting VLAN 10, 20, and 30. Type, can we configure it to support only 10 and 20? Yes. Yes, we can. You will see this later on. Now, by default, supporting which tagging standard? Supports 802.1 queue trunking. So it supports 802.1q for coordinating what? Trunk on fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet interfaces as well. So according to this figure now, we have two links between S1 and S2 and S1 and S3. These links configured as a trunk to transmit the traffic, for example, coming from VLAN 10, 20, and 30 across the entire network. Now, to understand now the situation and why we need the VLAN, let us have two scenarios. A scenario, we have multiple switched network without VLAN. As you see, all of the devices are in the same IP range. They are having the same subnet. So network address is 172.17.40.0 for all the connected devices. So let us assume PC1 here sends a broadcast frame, and the broadcast frame is received on F011 by S2. So what will happen? We do not have any VLANs here. Simply, the switch will forward the broadcast frame to all other devices except of the port or the broadcast port which the message received from. So in this case, all the devices configured on the same subnet network 172.17.40.0, and there are no VLAN configured. So what will happen? PC1 will send a broadcast frame to S2. S2 simply will forward the broadcast frame to all of its ports. So the broadcast will be received by PC2, S1. S1 will send the broadcast to S3. S3 will forward it to all ports. So PC4, PC5, PC6. So all network devices receive the broadcast frame in case no VLAN was configured in this network. So now let us talk about the same situation, but we have a VLAN configured on the Cisco switched boards. So as we see, we have two different VLANs, 10 and 20, each one with a different IP range, 172.17.10.0, 172.17.20.0. Now, VLAN trunk between S2 and S1 and S3 and S1 configured by default to support, or configured, sorry, not by default, to support VLAN 10 and 20, or it's by default support 10 and 20. So what if PC1 here send a unicast or a broadcast to all the devices associated with VLAN 10? Now, the broadcast will be tagged with a VLAN ID 10 when it's received by the switch. So when S1 here receives the broadcast frame on which port F01, S1 will only forward the broadcast frame only to other port configured to support VLAN 10. So port F03 configured to support VLAN 10. So the message will be sent to S3. Now when S3 receives the broadcast frame on port F03, also S3 will forward the broadcast frame here only out to the ports configured to support VLAN 10 only. According to this figure, only F011 is configured or assigned VLAN 10. So only BC4 will receive the broadcast message. So we have a smaller broadcast domain. And this is one of the main benefits of what? VLANs. Improve bandwidth, network performance, smaller broadcast domain. So with a VLAN, unicast, multicast broadcast traffic is configured on VLAN without a layer 3 devices. There is no routing is needed to connect the VLAN devices in different VLANs. Now, devices in different VLAN cannot communicate with each other. Devices with the same VLAN can communicate with each other across a multiple switched network without needing for a routing device. Now, let us talk about the native and the tag network. Now, as we have mentioned, standard Ethernet frame now, as you see, standard Ethernet frame header do not contain any information about the VLAN to which the frame belongs. And we have mentioned all Ethernet frame should be tagged with a VLAN ID. So, when any Ethernet frame here are placed on the trunk, information about the VLAN should be added. This Ethernet frame belongs to which VLAN? We should add this information. Now, how this information will be added? By using IEEE 8021.Q. What we call this process? Tagging. Now, simply, tagging process is done by inserting 4 bytes tag within the original Ethernet frame header in order to specify the VLAN to which the frame belongs. So we have the original Ethernet frame. On the trunk, Ethernet frame should be tagged. So we add a field size is 4, or the tag. We call this a process tagging. Tag is 4 byte size and it's divided into 4 fields. So when we insert the tag into Ethernet frame, how it will be inserted? 8021Q standards. Now, when the tag is created, frame check sequence must be recalculated here. And when sent to the end devices, the tag must be removed and the frame check sequence should be recalculated back to its original number. So main benefits of the tag is to handle the Ethernet frame within what? The trunk network, within the trunk link. If it's untagged, it will be tagged with a VLAN ID, what? The VLAN ID of the native VLAN, in case it's not tagged or it's generated within the switch, or it's a management, or from a management VLAN, or legacy devices like the hub or access points. So according to IEEE 802.1, we have 4 fields. Field 1 is the type, 2 byte fields, and always it's assigned the hexadecimal value 8100. This is referred to as a tag protocol ID. User priority, 3-bit value, support the level of service implementation. Priority. And it can assign the value, by the way, from 0 to 7. Usually 6 and 7 are not widely used. Canonical format identifier. It's a 1-bit value that can support a legacy network like token ring frames on the Ethernet, Most important now field, the last one, VLAN ID. VID, which is a 12-bit VLAN identifier that can support up to 4069 VLANs. Why 4060 lines? According to the number of bits, because it's a 12-bit. So in this case, what's the VLAN ID of the tagged Ethernet frame? 10. When BC1 sent to S2, so the VLAN ID here is 10. VLAN ID is 10 within the tagged frame. When BC4 receive it, we'll remove the tag frame and we will recalculate what? The frame check sequence one more time. Now, this scenario illustrates the native VLAN case. So when the switch here receives the frame on a board configured in an access mode and assigned a VLAN, what the switch will board? The switch insert the VLAN tag in the frame header, recalculate the frame check sequence, and send the tagged frame out the trunk port. This is the now. What we have here, as we said one more time, 802.1q standards specifies the native VLAN for the trunk link. Now, native VLAN by default is VLAN 1. So let us assume native VLAN is not configured. So any untagged traffic will be tagged or will be placed into native VLAN. So when any untagged frame arrives on a trunk port, it is assigned to the native VLAN. What's the native VLAN here scenario? VLAN 1. So management frames usually sent between the switches as or consider as an example of untagged traffic. Legacy devices like the hub here also can generate untagged traffic. Now, in case we have a link, if the link between two switches here is a trunk, the switch sends the untagged traffic to the native VLAN. Any untagged traffic will be sent or replaced to native VLAN. So here BC1 sends a frame. Now the hub generated on the trunk link untagged traffic. Now what's the native VLAN for any untagged traffic? 10. So untagged traffic will be placed on all ports of native VLAN. So it will be sent to this switch as a native VLAN, VLAN 1. It will be received. It will be forwarded to the other switch with a VLAN ID is the native VLAN, which is VLAN 1. Now, a trunk port for unsigned VLAN 1, another switch will receive it for VLAN 1. So, tagging is typically done on all VLAN. The use of native VLAN was designed for legacy use like the hub in this example or management traffic generated by the switch. Unless changed, the native VLAN 1 is the native VLAN unless it's changed to a different one. Now, both ends of the trunk must be configured with the same native VLAN. Native VLAN 1, VLAN 1, VLAN 1, VLAN 1. Each trunk now is configured separately, so it's possible to have different native VLAN on separate trunks. As we see here, for example, for this trunk, we have two different VLANs, VLAN 2, VLAN 3, VLAN 1 and 2. So we might have multiple VLANs on what? On the same trunk, or the same trunk will support multiple VLANs, or multiple native, VLAN. Now, remember when we talk about the voice VLAN, we said voice VLAN should be configured separately. Now, let us discuss the voice VLAN tagging in more details. Now, in general, what we have here, we have Cisco IP phone. Please focus with me here in the figure. Forget what is written now. Now, Cisco IP phone contains in general 3 integrated ports. These ports provide dedicated connection for the following devices. I'm talking about the Cisco IP phone and the 3 integrated ports. Now, port 1 usually connects to switch or other VoIP device. So as we see here, port 1 on the Cisco IP phone is connected with S3. Now, port 2 usually is internal port or internal interface used to carry the IP phone traffic. Now, port 3 is access port, connects to a PC or any other device. Now, as you see, we said port 2 is internal port, carries the IP phone traffic. So, port 2 configured to tag the voice traffic with VLAN 150. Now, switch access port now will send Cisco Discovery Protocol here. We need to use the Cisco Discovery Protocol. Why? In order to instruct the IP phone, the attached IP phone, to send the voice traffic in one of 3 ways. So for the Cisco IP phone, we have 3 ports, 1, 2, 3. Port 1 connected to Cisco switch. Port 2 is locally to handle the voice traffic. Port 3 connected to PC in this scenario now. Access port, Cisco access port or the switch, access port will send an instruction to the IP phone. Why? In order to inform it how to send the voice traffic. Now, the voice traffic can be sent by using 3 different methods based on the type of the traffic. Why? Because PC5 might send here a data traffic, but the IP phone will send what here? A voice traffic. So F018 should support now here what? VLAN 20 and VLAN 150. So how the IP phone will forward the traffic? We can use one of 3 methods according to the traffic type. So if the traffic type is voice VLAN, traffic must be tagged here with appropriate layer 2, class 150, and class of service or cost of service, priority value, quality of service. If the traffic is access VLAN, it can be also tagged with layer 2 switch and cost of service or quality of service priority value, high, low, medium, average. If the traffic is access VLAN, it's not tagged, so no cost of service or quality of service priority value in this case. So VoIP IP phone has 3 ports as we have mentioned, port 1 and 2 or 3. The switch will use the Cisco Discovery protocol to inform the phone of the voice VLAN how to forward the traffic or to send the voice traffic. 3 different ways can be used according to this table based on what traffic type. Voice, we have a tag and the quality of service. Access, it can be tagged with a quality priority. Access LAN, it will not be tagged. There is no priority values. So the phone may or may not tag a frames from PC5. Why? Voice should be tagged with 150. Data should be tagged with 20. Data from the PC will not tagged by the IP phone. It will be directly from PC5 to what? To F018 as a VLAN with 20. So there is no priority, there is no quality of service at all in this case. So according to what we have see here, fast Ethernet 018 on AC3 should be configured to serve or assigned with 2 VLANs. Data VLAN, for example, VLAN 20, voice traffic or voice VLAN, according to this example, it should be the voice VLAN 150. So, if we issue or perform the command show interfaces fast Ethernet 01 switch port. Command, we can see that the switch port here support both data and voice VLAN, and both of them assigned to the interface. How? Access mode, here it's VLAN 20, voice VLAN 150 on the same interface, fast Ethernet 018. Now, what's the access? Access usually between the PC and the switch. The connection mode should be an access mode here. A trunk mode usually between a switches and between switch and router. So between S1 and R1 is a trunk. Between S1 and S3 is a trunk. Between PC and S3 is access link here. So we have an access and we have a trunk link. أي سؤال إلى الآن؟ طيب, VLAN configuration, it will be a very simple now. Now, when configuring a normal range VLANs, the configuration details will be stored in the flash memory on the switch in a file called VLAN.dat. Now, before we talk about the configuration of the VLAN, we need to talk about this table. Usually, VLAN divided into main 2 ranges of VLAN IDs. Now, Cisco switches like 2960, 3650, they support up to or over 4000 VLAN. To be more specified, 4060 line VLANs. Now, so ID VLAN 1, 2, 3, 4, 5, 6, 7 until 4000. In general, it divided into 2 ranges. Normal range of VLANs and extended range. Normal range usually between 1, VLAN 1 and VLAN 1005. Main features used in small and medium size of business. Now, 1002, 1005 are reserved for legacy VLAN. VLAN ID 1, 2, 1001 and 5 are auto-created and cannot be deleted. Usually, all VLAN configuration will be stored in the flash memory in a file named VLAN.dat. And the flash memory here is persistent, so we do not need to copy the configuration when we configure the VLAN. It will be stored by default. Finally, VLAN trunking protocol is used to synchronize the VLAN database between the switches. Now, range from 1006 until 4095 used by service provider are in running config. The configuration of the running config file supports fewer VLAN features compared with a normal range, requires VLAN trunking protocol configuration. So we'll work with the normal VLAN ranges as you will see in the configuration now. How we can configure a VLAN? Configuration will go through steps. Step 1, we need to create a VLAN. We need to create VLAN 10, VLAN 20, VLAN 30 according to the figures we have discussed before. So, for example, this is a type of a final exam question. They will ask you write a command needed to create VLAN with an ID 100, for example. So what's the steps? Step 1, we need to enter the global configuration mode. So from the privileged configure terminal or config terminal, so we enter the global configuration mode. We will use the command VLAN followed by a parameter or a keyword VLAN ID. So VLAN 10, VLAN 20, VLAN 30, VLAN 40, and so on. So we are going to create a VLAN with a valid ID number. Now we need to specify a name to this VLAN. Faculty, students, guest, technician, management, IT, administrator, any name. So name followed by the VLAN name. So specify a unique name to identify the VLAN. After that, we have created a VLAN with a specific ID and name, so we can exit to the privileged exit mode by using the command end. Now for this line, no needed, so it's just repeated one more time. So we can simply remove this row. So we have 1, 2, 3 steps in order to create a VLAN. Now if a student, according to this figure, is going to be in VLAN 20, we will create the VLAN first and then name it. So how we can create the VLAN on a switch 1? Configure terminal, VLAN 20, name student. We have created the VLAN 20. If we do not name it, the Cisco will give a default name to any VLAN. The default name usually will be the VLAN word followed by 4 digits number. So for example, if we just issue the command VLAN 20 without use the name and assign the name student to the VLAN, Cisco switch will assign the name VLAN with a 4 digits 0020. So student's computer here, PC2, has not been assigned to VLAN yet, but PC2 here assigned what? Assigned IP address, and this IP address belongs to the VLAN 20, range of the IPs of VLAN 20. As you see, the configuration is at the switch side, not at the PC side. At the PC, simply we need to assign an IP within the VLAN range. That's all. Now, once the VLAN is created, now we can assign the VLAN to the correct interface. How? Configure terminal. Now, interface followed by the interface ID. So, interface fast Ethernet 018 on S1. Now, we must set the access mode of the port. Access mode can be or access. The mode of the port can be a trunk or access. If it's between a PC and a switch, the port should be configured as what? As an access mode. Cannot be configured as what? As a trunk. It should be configured as an access mode. So one more time, we enter the global configuration, interface fast Ethernet 018, switch port access, in order to set the ports to the access mode. Now, this command is not mandatory. It's an optional command, by the way, but it's strongly recommended to issue these commands. Now, what's the access mode? Access mode here indicates that the ports belongs to a single VLAN will not negotiate to become a trunk. Once we said this interface ID is an access, this interface in the future will not try to become a trunk. It will remain always access port. Now, once we configure the interface, now we need to assign this interface to a VLAN. So switch port, access, VLAN. What's the VLAN ID? ID 20 in this example. So how I can configure fast Ethernet 018? I will follow the steps. Configure terminal, interface fast Ethernet 018. Now we need to set the access mode. Switch port mode access. Now we need to assign the port to a VLAN. Switch port access VLAN. What's the ID of the VLAN? 20. So we can assign the VLAN to the port interface. Once the device is assigned the VLAN, then the end device will need the IP information for that VLAN. When VLAN 20 is configured on the other switches, the administrator must configure the student computer to be in the same subnet. What's the subnet? 172.17.20.0. So what's the student IP here? 172.17.20.22, which is on the same network range. So once the PC is connected to this switch, the PC will now consider as a part of what? VLAN 20. Or it will be assigned automatically the VLAN 20. Why? Because it's connected to a switchboard configured with VLAN 20 and the IP within the same range of VLAN 20. So the steps is create the VLAN by using two commands quickly: VLAN ID, VLAN name. After that, we need to configure the switch port interface followed by the ID of the interface. We need to set the access mode, switch port mode access. We should assign a VLAN to the port, switch port access VLAN followed by the ID. Once the PC connected, admin should configure the PC within an IP for that network, and the PC will automatically become a part of this VLAN. Now, keep in your mind that the access port now here may assign only one data VLAN or can assign only one data VLAN, but in some cases it can assign a different VLAN like the voice VLAN. When a phone and an end device are off of the same switchboard. So what we have here, now here we have a PC connected to S3 at fast Ethernet 018 port. IP phone attached to S3 within the same port. So the port here will or should support two different VLAN traffic. Data traffic for PC5, voice traffic for the IP phone. So we should configure the port to support both of them. So how a port can be configured to support two different VLAN? We need to create now both of them. We need to create a voice and data VLAN. So according to the configuration here, we are creating VLAN 20, VLAN followed by the ID 20, name student, VLAN 150, name, voice. We exit the configuration now here. Now we need to configure the interface. Fast Ethernet 018. Now in addition, now after we create the VLAN, in addition to assigning the data VLAN, we also assign the voice VLAN and turn on the quality of service for voice traffic in the interface. Now, in general, in your Catalyst switch will automatically create the VLAN if it does not already exist when it's assigned an interface, which means if we directly start with the configuration without creating the VLAN, some newer switches will automatically create the VLAN if the VLAN ID is not valid. Now, how a quality of service will be allowed? The voice for the VLAN 150. Quality of service is beyond the scope of this course, but the user must use this command, MLS, quality of service, trust, okay, a quality of service or cost of service. We must issue this command to allow the quality of service. This command usually used to set the trusted state of an interface and to indicate which field of the bucket are used to classify the traffic. So now back to the interface 018, we need to configure it to support the data traffic for VLAN 20. So switch port mode access, switch port access VLAN 20. Now it will support VLAN 150, it's a voice, we need a quality of service. So MLS, quality of service, trust, cost of service, COS. Now switch port, voice, VLAN 150. Once we complete these two steps, now fast Ethernet on S1 port 018 supporting voice traffic on VLAN 150, data traffic or user traffic on VLAN 20. Finally, now verify the VLAN information. We can use the command show VLAN commands with the following syntax. Show VLAN brief, show VLAN ID followed by the ID name. We can use show VLAN name followed by the VLAN name, or we can use show VLAN summary. in order to verify an information about the VLAN. Now, so usually if we issue the command or use the command show VLAN with the option brief, it will display the VLAN name, status, and its ports on the VLAN pair line. If we use show VLAN commands with the option ID followed by the ID name, display information about the identified VLAN ID number. In case we use the option name, it will display information about the identified name. VLAN name is an ASCII string from 1 to 32 characters. If we use the summary option, it will display a VLAN summary information. As you see here, in this example, we use show VLAN summary. So number of existing VLAN 7, number of the VLAN trunking boards here is 7 as well. We can use show interface VLAN 20. So in order to check the status, VLAN 20 is up, line of protocol is up, for example. Now, a simple question. Can we change the VLAN board membership? What's the membership of VLAN board for F018, 20, and 150? Now I need to change the VLAN 20 and set it to 1 or 10. So how we can change the membership of a Cisco switch? We have two ways, or there are a number of ways in order to change the VLAN membership. The first one, simply will re-enter the switch port access VLAN command. So for fast Ethernet 018, it was a switch port access VLAN 20. Simply re-enter the command with a different VLAN ID. So switch port access VLAN 10. Switch port access VLAN 100, switch port access VLAN 99, and so on. So this is one of the options. Second option, we can use no switch port access VLAN. Once the command is placed or executed, the port will be a membership of the default VLAN by default. It will be what? Back to the default VLAN. So we can use no switch port access VLAN to place the interface back to the default VLAN. In our example, the default VLAN is VLAN 1. So as you see here, interface fast Ethernet 018. On the interface, we have run the command no switch port access VLAN. When we use the command show VLAN brief, as you see now, we have information about the default VLAN. Fast Ethernet 018 become a member of the default VLAN. Before that, it was a member of VLAN 20. Now we have another VLAN available, VLAN 20. The name of the VLAN is student, the status of the VLAN active, as you see here. Also, we can use the command show VLAN brief or show interface, the interface ID, fast Ethernet, for example, 018 switch port command to verify the correct VLAN associated. So here we use the second option, show interface fast Ethernet 018 switch port commands. So what's the access mode? What's the default VLAN here? Is 1. After we run no switch port access VLAN. So we can check the default VLAN either by using show interfaces, the interface ID switch port command, or we can use show VLAN brief. Can we delete the VLANs? Yes, delete VLANs with the no VLAN followed by the ID number. So no VLAN 10, no VLAN 20, no VLAN 30, no VLAN any VLAN ID number. Be careful before deleting the VLAN. Reassigning all members port to a different VLAN. We can delete all the VLANs with a delete command, flash colon VLAN.dat file, or delete VLAN.dat commands. After we delete or empty the files, we must reload the switch when we're deleting all the VLANs. To restore to the default factory, unplug all the data cable, erase the startup configuration, and delete the VLAN.dat file, then reload the device or the switch as well. So we'll have the factory sitting on the device in this case. Now, back to the trunk. Now we need to talk about the trunk configuration because we have already configured one here, the access mode. The mode is access, so between a PC and the switch port. Remember, trunk between the switches, and the trunk usually configured to carry all VLANs, to support all VLANs. Now, in order to configure any switch port as a trunk port, we need to follow the following steps. Step 1, we need to enter to the global configuration mode by using the commands configure terminal. We need to enter the interface configuration mode, the interface ID. Now we need to set the switch port to permanent trunking mode. Now it's not access trunking, so switch port mode trunk. Set the native VLAN to something else other than VLAN 1. So switch port now trunk native VLAN, for example, VLAN 99. We can create any VLAN, we can use it as a native VLAN. Now specify the list of VLAN to be allowed on the trunk. This trunk will allow which VLAN traffic to go through it. Simply like this. So we can say switch port trunk allow VLAN with a VLAN list 10, 20, 30, or we can simply use a range 10, for example, to 30 as an example. Once we're done with these steps, switch port now is configured to be a trunk port permanently, which means also it will not negotiate to become a trunk. It's a permanent trunk, no need for any negotiation. What's the negotiation? I will talk about it now. So, as an example here, let us check this case. We have S2. We have how many PCs attached to the S2? PC1, which are part of the faculty VLAN. The ID of the VLAN is 10, a student VLAN 20, guest VLAN 30. Now, what's the type of the connection between PC and S2? Access. Now, what's the type of the connection between S2 and S1? Through fast Ethernet 01. A trunk here. Now, here is a trunk. Now, the subset or the subnet, associated with each VLAN are the following. VLAN 10, called faculty or staff. The IP range is 172.17.10.0. VLAN 20, 172.17.20. VLAN 30. And we have a native VLAN 99. The IP range is 172.17.99.0. Now, Fast Ethernet 01 port on S1 will be configured as a trunk port. How? We need to follow the steps. We are assuming that we already create VLAN 10, 20, 30, and 99. So we need to access the interface. Interface Fast Ethernet 01. Now we need to set the mode permanently to trunk. So switch port mode trunk. Now we need to set a native VLAN in order to handle what and tag the untagged traffic. So switch port trunk native VLAN 99. Now we need to configure which VLAN allowed through this trunk. Switch port trunk allowed VLAN 10, 20, 30, 99. Now this configuration assumes a 2960 switch using 802.1q tagging. Layer 3 switches requires the encapsulation to be configured before the trunk mode is configured, and we will see this scenario. When we use layer 3, we must configure the encapsulation mode as IEEE 802.1.q by default. But we are assuming that this switch already using 802.1q tagging. So no need to configure the encapsulation. So is there any question until now? Now, how we can verify the trunk configuration? We can use show interfaces Fast Ethernet 01 switch port command. Now forget what we have here. Now according to the output, what we can see that the switch port is enabled. The access mode is trunk. Fast Ethernet 01 port is set as a trunk and operation function without any problem. The encapsulation is .1q. .1q is the name referring to the IEEE 802.1q. So it's already configured. No need to configure the encapsulation for the untagged traffic. Now, native VLAN is 99. Now, trunk VLAN here enable all. So, switch port is a trunk port. Allow all VLANs created on the switch to pass the traffic on this trunk. So, VLAN 10, 20, 30, 99 can pass the traffic through Fast Ethernet 01. Now, how we can reset the trunk to the default state now? How we can change the default VLAN? Now, what's the native VLAN? The native VLAN is 99. Now, in order to reset the trunk setting, we will use no command. No command as the following. Interface Fast Ethernet 01. Now, no switch port trunk allowed VLAN. What's the benefit of this command? Simply this command will remove the allowed VLAN and reset the native VLAN of the trunk. So, no switch port trunk allowed VLAN, which means all the VLANs now are allowed in this trunk. Not only 10, 20, 30, and 99. No switch port trunk native VLAN. We are going to reset the native VLAN. Native VLAN will be reset. It was what? 99. Now, what's the native VLAN after we issue no switchboard trunk native VLAN? It's a VLAN 1. So we are resetting the switch or board by using two commands. No switchboard trunk allowed VLAN. So now all VLAN allowed in this trunk. No switchboard trunk native VLAN, which means now the trunk port will reset the native VLAN to the default native VLAN, which is by default on the switch VLAN 1. 1 second, please. So reset the trunk to the access mode. So if we have configured the trunk or set the port as a trunk mode, can we change it to the access mode? Yes. Simply we will re-enter switchboard mode access instead of switchboard mode trunk. So switchboard mode access, it was a trunk. Show interface fast Ethernet 01 switchboard. What's the access mode now? It's a permanent access, not a trunk. Now, last part in module 3, dynamic trunking protocol. Quickly, what's the dynamic trunking protocol? Dynamic trunking protocol allows the switchboard to negotiate to become a trunk if it's not a trunk. This is the main feature or the main function. So dynamic trunking protocol is a Cisco protocol. Interface now can be set to trunking, non-trunking, or to negotiate a trunk with a neighbor interface. Now, trunk negotiation is managed by dynamic trunking protocol, which operates in point-to-point basis only. So, between a switchboard and another switchboard only, between network devices. Now, what are the main characteristics of the dynamic trunking protocol? It's on by default on a Cisco switch, Catalyst 2960 and 2950. It's a dynamic auto by default on Cisco 2960 and 2950, which means now dynamic auto, it can start negotiation to become a trunk. It can be turned off with non-negotiate commands, so a switchboard non-negotiate, we turn it off. We turn off what? Dynamic trunking protocol. It may be turned back on by setting the interface to dynamic auto. So switchboard mode dynamic auto, we turning on back what? The DTP. Setting the switch to a static trunk or static access will avoid negotiation issues, so we can use a switchboard mode trunk, no negotiation, or a switchboard mode access. So switchboard mode trunk, we can switch off the TTP, turn it off, switchboard, non-negotiate, so it will not negotiate. We can turn it on back, switchboard mode dynamic auto. Now, switchboard commands, when we talk about the negotiation, will have 4 options. So we can say switchboard non-negotiate. In this case, the interface is configured to stop the DTP negotiation in case we use this command. But we can use the switchboard mode with 4 different options. Please focus here. If we have used these commands as the following: switchboard mode access. So it's an access board. What does that mean? It means that this switchboard is configured as an access mode, and it will negotiate to convert the neighboring link into access link only. So it's an access, and it will negotiate with the other point to become an access only. Now, if we have a switchboard mode dynamic auto, what does that mean? It will become a trunk interface if the neighboring interface is set to trunk or desirable mode. So we have a switch, and this one is configured as dynamic auto. It will become a trunk if the other side is a trunk or configured as desirable. Now, switchboard mode dynamic desirable. It will seek to become a trunk by negotiate with the other auto or desirable interface only. So it will negotiate to become a trunk if the other end is configured dynamic auto or desirable interface only. Finally, switchboard mode trunk, bare minimally trunk, and it will negotiate to convert the other neighbor link to become a trunk. So we can summarize all of these options in this table. So what we have here a switch with two ends. So this is the interface of S1, for example, and this is the interface of S2. So if the switch mode option is dynamic auto and the other one is dynamic auto, in this case it's an axis. The board or the link will be an axis. If it's a dynamic desirable and the other net, or sorry, dynamic auto with dynamic desirable, it's a trunk. Dynamic auto with a trunk, it will be a trunk. Dynamic auto with an axis, it's an axis link. Now, dynamic desirable with dynamic auto, it will negotiate as a trunk. Dynamic desirable with dynamic desirable, a trunk. Dynamic with a trunk, axis with dynamic axis. Now, a trunk with dynamic trunk, trunk with dynamic desirable trunk, trunk with a trunk by default is a static trunk. Now, a trunk, one of the sides is a trunk and the other one is axis. What does that mean? Limited connectivity. So what does limited connectivity means? It means that only the VLAN can communicate is the native VLAN here. Only native VLAN can communicate. This is what does limited access means. So in case of the access, regardless of its dynamic, desirable or auto, it should be an axis. With an axis. Now with a trunk, same case, limited connectivity, which means only this communication is valid for the native VLAN. Finally, how we can verify the dynamic trunking protocol. The default dynamic trunking protocol configuration depends on the Cisco iOS version and the platform. We can use show DTP interface command to determine the current DTP mode. Best practice recommend that the interface be set to access or a trunk and turn off the DTP, non-negotiate another way. So as you see here, we have use show DTP interface for fast Ethernet 01. fast Ethernet 01. So it's an axis. Sorry, it's not an axis. It's a trunk mode. It should be between the other switches. So according to the output, we have multiple outputs. For example, TOS, TS, TNS, no need to explain all of them. I will explain this line only. It means the trunk operational status, the trunk administrative status, and the trunk negotiate status. Operational, which means what we are doing at this moment. So as you see, it's an axis. Now negotiate or administrative, status. Who configure it? Auto configuration. And for the negotiation, we ask for the during of the negotiation. So it's an axis, auto axis, native, negotiate, native, and some other details about this interface. Now this is the end of not the class, the end of module 3. I'm going to start with module 4 immediately. One second. Now, what we will talk about in module 4, we still have 15 minutes, so let us cover whatever we can cover, and we will continue next Sunday within the office hour as usual. Inter-VLAN routing operation. Now, what's the inter-VLAN? VLAN are used to segment a switched layer 2 network for a variety of reasons. Now, regardless of the reason, hosts in one VLAN cannot communicate with hosts in another VLAN unless there is a router or layer 3 switch to provide routing services. Now we have some hosts in VLAN and another host within the same VLAN but in different switch. Hosts cannot communicate with each other in this case unless we have between them a device support layer 3 switching or a routing services. Now, what's the layer 3 switch device? It's a device provide the services as a switch, and it can act as a router to perform the routing functions. So inter-VLAN routing is a process of forward the traffic from one VLAN to another VLAN. In general, we have a 3 inter-VLAN routing option. Legacy inter-VLAN routing, router on a stick. This is acceptable solution for a smaller to medium-sized network. Layer 3 switch using SVI switch virtual interfaces. This is the most scalable solution for medium to the large organization. So why we need the inter-VLAN? To allow VLAN in one network to communicate with other devices in different network assigned to the same VLAN. So now let us discuss the first routing option. We will use the legacy inter-VLAN. Now legacy inter-VLAN is not used anymore, so we'll discuss it only within this slide. The first inter-VLAN routing solution depends on using a router. We need a router, and the router should contain multiple Ethernet interfaces. Now, each router interface will connect to a switch port in different VLAN. So, BC1 here assigned VLAN 10, connect to the switch. S1 fast Ethernet 01 attached to the router through gigabit 000. R1 attached to S1 as well on gigabit 001, and S1 connected with BC20. Sorry. Now, why we need the routing? To allow devices on different VLAN. Now, different VLAN can communicate with each other through the inter VLAN. We are not talking about the same VLAN. So BC here 1 can communicate with BC2, which attached to different VLAN. So in the legacy inter VLAN, multiple interfaces needed on the router. Every interface or physical interface will be connected to the switch in different VLAN. Now the router interface will serve as a default gateway on the local host on the VLAN subnet. So what's the default gateway for VLAN 10? Router interface 192.168.10.1. What's the default gateway for all the PCs on VLAN 20 192.168.20.1? It's access or acting as a default gateway. Now, legacy inter-VLAN routing using the physical interface network, but it has a significant limitation. What's the main limitation? It's not reasonably scalable because the router will have a limited number of physical interfaces. We need a separate interface for each VLAN. So one physical router interface per VLAN is needed, and in this case we can consume all the physical capacity on the router quickly. This mode or this method of inter-VLAN routing is no longer implemented at all in a switched network, and it's included only to understand how inter or legacy inter-VLAN routing is operated. So we need a router, physical interface. Every physical interface in the router will be attached with a specific VLAN, and it will be act as a default gateway for all hosts within that VLAN. Now, router on a stick inter-VLAN routing. Now, router on a stick inter-VLAN method overcomes the limitation of the legacy inter-VLAN, which means it's scalable in some way. It only requires one physical Ethernet interface to route the traffic between multiple VLANs on the network. So we need only one Ethernet or physical interface on the router. This physical interface can support the communication between multiple VLANs. Now, Cisco iOS router Ethernet interface is configured as an 802.1Q trunk and connects to a trunk port on layer 2 switches. Specifically, the router interface is configured using sub-interfaces to identify the routable VLAN. Let me simplify it to you. A single interface will be configured to include multiple sub-interfaces. These sub-interfaces will be used to support different VLAN, or each sub will be assigned an IP belong to specific VLAN, so it will related to that VLAN. So the router will process the routing operation as the router by using the IPs of the sub-interfaces as if a normal operation of a routing at the router and the routing table. So we need to configure a physical Ethernet device with sub-interfaces. The configured now sub-interfaces are software-based virtual interface. Every sub-interface will be associated to a single physical interface. Now, sub-interfaces are virtual and are configured in a software on the router. Now, every interface will be configured with an IP address and VLAN. Assignment: sub-interfaces will be configured for different subnets that corresponding to their VLAN assignment in order to facilitate the logical routing process. Now, simply when the VLAN is tagged or when a VLAN tagged traffic enter a router interface, it will forward it to the VLAN sub-interface. So from an interface to the VLAN sub-interface, after the routing decision will be made based on the IP or the destination IP address, the router will determine which exit interface for data traffic. The exit interface will support 802.1q, configured as 802.1q sub-interface. Data frame are VLAN tagged with a new VLAN and sent back to the physical interface. Simply as this, we have a sub-interfaces configured for different VLAN with an IP. The tagged traffic will enter the router. IP destination address will be checked. According to the destination address, the message will be routed to the correct physical with a correct sub-interface. All sub-interfaces are virtual. It's a software based on the router, and router on a stake method can support or can be scaled to support up to 50 VLANs. So we can have, for example, 50 different sub-interfaces in this case. Last and most, let me say, efficient solution is the inter-routing on layer 3 switch or inter-VLAN routing or layer 3 switch. Now, modern methods to perform the inter-VLAN routing is to use layer 3 switches and the switch virtual interfaces. Switch virtual interface is configured or is a virtual interface that is configured on layer 3 switch, as we can see in the figure below. Now, what's the layer 3 switch? It's a switch acting as a router and simply a normal switch or layer 2 switch. As we see here, we call the layer 3 switch a multiple or multi-layer switch, as it's operates at layer 2 and layer 3. Now, in this case, we have VLAN 10. We have a switch attached to multi-layer switch. Now, we have or we need to configure a switch virtual interface on layer 3 switch to support VLAN 10. It will be used as a default gateway for VLAN 10 hosts. Another switch virtual interface on layer 3 device to support or assign an IP as a default gateway of VLAN 20. All VLAN 20 now can use this SVI switch virtual interface to communicate with any other host located on different VLAN. So two different VLAN can exchange a traffic between them through layer 3 switch by using a switch virtual interfaces on each part. Now, inter-VLAN switch virtual interface are created in the same way that the management VLAN interface is configured. SVI is created on the VLAN that exists on the switch. Also, virtual, the SVI performs the same function for the VLAN as the router interface would. Same function as a router. It provides layer 3 processing for packets that are sent from all switchboard associated with that VLAN. Main advantages of using layer 3 switches are the following. They are much faster than router on stick because everything is a switched here and routed. No need for external link from the switch to the router for routing. There are no limited to one link because layer 2 Ethernet channels can be used as a trunk link between the switches to increase the bandwidth. Latency is much lower because data does not need to leave the switch in order to be routed to different networks. Now, finally, more commonly deployed in campus LAN than routers. The only disadvantage is that the cost, which is more expensive. Type. We are going to stop here. And we will continue on Sunday. There is no an option.